Hi, I'm Mr. Pruis. I'm one of the Geosystems teachers at South Lakes. This is a short video to help you understand how we use the ArcGIS Online map for this lab today. All right. One thing to make sure you understand about hotspots is they are a unique volcanic feature. They are these places in the earth where sources of volcanism are relatively stationary, and the plates move over the surface of the earth relative to these stationary hotspots. And because of this interesting behavior, we're able to determine the direction and the speed that plates are moving. And that's the purpose of today's lab, is for you to calculate the rate of the plate motion. Okay? So the lab here, you can do this two ways. If you prefer, you can use the paper map and do the process using the information that's been added to the map. There's a little bit more work to do, but it does work. Especially if you have trouble with an internet connection, this might be the way to go. Okay, but if you want to do the lesson using the interactive map, you click the orange link here, and in the next section of the map, or the next section of the activity, we will use this green map for the Yellowstone example. Okay, the process is very simple. Let me explain it for you right now. So you click this link and you get to this map. And you might want to center it up a little bit more and zoom in if you can. Yeah, that'll be about the right place to zoom into. All right, and then what your purpose in this lab is to determine the rate of plate motion. But to do that, you need two pieces of information. You need to know the ages of islands, and you need to know the distance between them, so you can calculate how fast the plates are moving in centimeters per year. To start this process, I'll do an example. I'm just going to measure between these 2 points here. All right, and I'm going to start by finding the measure tool at the top and click on the part that says distance, the button that says distance, change the miles to kilometers, and then click at the base of the point and then drag the blue line. You don't even have to you don't have to hold the button down, just click once and then move the mouse to the next point and click again, double tap, and then it finishes. Double click. That's 1,905 kilometers. Now if you wanted to change that to centimeters, because you're calculating the rate in centimeters per year, what you need to do is simply add 5 zeros to that. So that would be 1905 00000, and now you have it in centimeters. Okay, so now you know the centimeters, but to get the age is even easier. Click on a point and you'll see the age is 5.6 million years. To turn that to millions of years number, you would write down 5600000. Okay, 5,600,000 years. Okay, and if you want to learn a little bit more about this place, you can click these pretty pictures. Notice that it's pretty weathered. It's an old island, 5.6 million years. Now to get the age of the other one, $16.2 million years. Okay, so that's going to be 162,000,000, 16,200,000 years. Okay, now how do you get the age or the time period between when these rocks formed and when these rocks formed? You subtract. So you subtract your 5,600,000 from 16,200,000 to get your difference in age. Okay, so everyone should get 10,600,000 years as the time that's passed between those two volcanoes forming. Now back in the lab, you scroll down and there's some questions to answer. These are general questions in the beginning, which island is youngest and so forth. But when you get to this orange box, this is where you record the distance that you measured. Okay, so it says how many kilometers in the real world. That was the number that you measured directly on the map. And then number 6 below it, that's where you would add the 5 zeros to that answer to convert it to centimeters. So remember, what I just did was an example. I did not do any part of the lab for you. I just showed you how to do it. So don't put the numbers that I just gave you into your lab. For part B, it's the Yellowstone hotspot lava fields section. And it's a similar process for a different hotspot. This is the Yellowstone hotspot. You may have heard all about the Yellowstone supervolcano. It has definitely been super explosive in the past. Not so much recently. Could it do it again? Sure. Am I going to lose any sleep? No. So click on this map. And this brings us to Idaho, Wyoming. Present day hotspot is over here in Yellowstone National Park. And all of these red blobs are former calderas that were explosive just like Yellowstone in the past. And why are they scattered off in this direction? It's because the plate's been moving. Okay, but how fast has it been moving? Well, it's the same process. You can click on the pin and it will tell you the age. Last time it erupted was about 600,000 years ago, so that's why the age is 0.6 million years. Okay, and then over here, this older looks like Awihi Humboldt volcanic field. This is an explosion that happened 14 million years ago. This is all the ash. All of this gray stuff in this photo is the ash and fallout from the volcano erupting. This person down here is standing on the actual surface of the earth that was cooked by the hot lava like a red brick. And that's the boundary between between the ash cloud, the hot ash, and the earth underneath. But that's great evidence of a massive explosion. That's some pretty thick layers of ash. Okay, so you do the same process. Use your measurement tool to get the distance, add your 5 zeros to get it to centimeters, and then do the age calculation and calculate your rate in centimeters per year. Okay, I hope this is helpful.